Hello all. With great pleasure, I welcome you to my talk about a long road from edge to a cloud. And today I wanted to share you a few stories and challenges related to industry IoT. I strongly encourage you to ask questions on the chat during the presentation. We will be answering those after the end of this session and afterwards in the formal Q&A session. So I should start with explaining a few things about myself. So my name is Rafał Warzycha. I'm technology evangelist and senior principal engineer. Please don't make fun of me. This is actually my working title. I work at ABB. This is well-known multinational company mainly from robotics and power industry, also electric industry. And there I am considered an IoT and edge expert. So I'm helping ABB doing a business with IoT, industry IoT to be precise, to create the products which are captivating and training personnel and the engineers with the latest technology, allow them to create the great software for our end customers. You may recognize my voice from JavaScript podcast called Just for Fun, and my shepherdship in the technology meetup, mainly in Łódź, like Meet.js. So my day-to-day job lies somewhere in between a business and technology. On the one side of my heart is dedicated to delivering these fantastic products. And another side is dedicated to knowledge sharing and technical solution, like problem solving, since I'm still tech savvy. I'm consulting an IoT solution, like from large ones and to even small ones, help with technology, help with the productization, training, workshops, and other engagements. So a lot of stuff actually. And mainly I'm focused recently on robotics. So you may find my work in robotics, but also power grids, smart grids to be exact, like a few years ago. And to give you a bit of context of slice of my life, this is how it looks actually. So this thing on the screen is called Edgeowisko. It's a bunch of edge devices. Those are enterprise edge devices, HP enterprise, with some HP mixed with ABB logos. The names of those trees, Geralt, Siri, and you may name it, from witches books and video games. So this is more or less how my desk or desk of the colleagues that I'm working with looks like. And those devices will actually land on the factories and the plants, gathering data from PLCs, so programmable logic boards, and sending those data in multiple places. Since I'm currently more involved in robotics, most of the pictures are not yet being shown since the COVID-19 situation. It's a great opportunity to help them, since there is a lot of push to deliver a solution based on the IoT, especially in the industry IoT. But to meet and greet them in physical form, that's completely different story. So when I will be able to travel back to Sweden again or Spain, I will make some more pictures. Yeah, I will be talking more about robotics in a few minutes, but before that, I think we should start with most basic things. So from the scope of what I will try to describe today would be industry IoT as a whole, and the data security, data ownership, and data processing. It's by no means all of the topics which are interesting. Those few I deemed to be interesting for the general public, and to get you to understand that the challenges that the guys from IoT world are struggling with are quite unique to the field, and we are looking for the people, bright people who can help us to build very complex system. And yeah, that's why this is quite unique field. I feel, and I'm quite confident that this field will be growing fast. And for some of you that maybe not associate yourself with Internet of Things, you may be wrong if we are talking about the sensors and we are talking about gathering data and showing data, telemetry data on the user experience, from the user experience perspective or analytics perspective or AI perspective. You are closer to Internet of Things than you may think. And this is a common denominator that I'm seeing through the project that I'm interacting with. The people are not even aware that they are doing Internet of Things, which is quite funny from one perspective, but from other perspective, there are some unique challenges that I want to describe today. So going into the details, you may know that picture from other conferences. I borrowed it from PubNob, but it's basically a good description of what I will be talking about today. Starting from bottom, we have an edge and the billions of devices which are connected and capable of sending data. And basically, in the Internet of Things landscape, we can divide it by the way where the live devices, the devices which are lying at the bottom of this pyramid are lying. If the devices are sitting in your home, therefore we have a smart home. If they are spread across your city, it's smart city. If they are lying in your factory, or the factories, we are speaking about industry, Internet of Things. So that's very diverse and complex area of software engineering and productization. So there is like a lot of hidden stuff there that I want to debunk also today. Like there is this middle layer that you may heard about. It's called fog, and this is basically a place when underutilized resources such as firewalls, PCs, or on-premise servers are lying and get basically utilizing electricity, doing almost nothing. And the whole point of this middle section of this pyramid is to utilize them in a more eco-friendly fashion, to actually use the resources that we have on hand before their life expectancy will expire, and to be able to use this load, like self-managed processing cluster capable of like higher loads than a single edge device or a leaf device from the bottom, to do the a lot of computation, which are not extremely heavy, but they are quite important from the perspective of like company or even like smart city. So cloud of those devices which are not being utilized at that time may be a good remedy or a sweet spot for medium loads, and in cases of in use cases such as report generation, machine learning, which take a lot of time and resource, but we don't need to get a result like now in milliseconds. And for the highest loads and burst, we have a cloud that will scale, should scale indefinitely, both horizontally, vertically, and even closed clouds. So with the third direction of scaling for clouds and data centers. We also can consider data centers by themselves as a cloud here, like private clouds, of course. Those are the most heavily muscles that are available for our processing. So the side story here is you may not be aware, but a lot of companies move their SAPs so ERP systems to clouds, like for example Azure or other. So to being able to remove the resources that are on-prem and basically capable of scaling easily on the cloud. Yeah. What about the use cases? I borrowed a few use cases from my actual clients, but they are quite common. But when we investigate the offerings between the different IoT providers, we can see the condition monitoring and diagnostic, which is quite typical, I would say, across all of the Internet of Things area. So to be able to see the actual KPIs of your devices or the whole systems, it's quite cool to have. And usually that's enough to get the information that everything is green or there are a few things yellow, but sometimes we would like to go deeper to see what we can optimize, to get some more information on what can be adjusted, or when the issue are arising, what we can do about those. What else? The backup management, that's quite typical also. It's available everywhere, starting from the cell phones that we have on our hands, the iClouds and other clouds that we can do the backup of our documents. And from the IoT perspective, so industry IoT perspective, it's typically the backup of larger systems, like in my case, the robots. And fleet management, since usually you don't buy a single robot, it's typically you buy a bunch of them. They are not cheap, but they do the work instead of humans. So that's a plus, and yeah, they just need electricity. So the fleet assessment or fleet asset optimization is all about seeing a big picture. When we do have hundreds of those robots working in EU cells, so the cells which are, for example, are doing painting or welding or other specific activities, we would like to be aware what those units are doing together, if they are like everything is going well or not. Same goes for like asset optimization. It's typically when this is since robots are both hardware and software. Hardware eventually will fade, and we need to be prepared for that, to either refurbish the robot itself or to exchange it with the new generation, new software, firmware, or any other. Last but not the least, the remote access. That's quite self-explanatory. And yeah, since, for example, the COVID-19, more and more companies are considering as an asset right now. And what I was observing through the last, I don't know, 3-4 years, that we have a large ramp up of the IoT, industry IoT knowledge in the companies all around the world. Right now, there is a strong push to do industry IoT, since it's a great benefit when you don't have to have a physical human on the side. If there is like this, you can always remotely connect to your robot, verify if everything is okay, and work from home. Of course, it's not always so pretty, and the critical failure may occur. So at time to time, there is this notion to, like, we need to send somebody to do the job which cannot be automatized or robotized. But the idea here is we would like to minimize the time that person may have to spend in such a scenario when in COVID situation, we are not sure if the travel to the site is secure and it will not compromise the well-being of the person. And from the robot perspective, it will not care about the COVID at all. So this is my story here, and you may see that the pictures are nice and like fewer incidents, faster response time, everything that's nice. But where's the catch? There are a few catches there, and let's start with the first one. So there are a few characteristics of industry IoT, which are quite unique compared to other IoTs. Those characteristics are secureness. And by security here, we mean that the device needs to operate outside of our control as a manufacturer. We're just sending those robots somewhere and we don't know what is happening physically in them. We don't have any cameras. We just have a telemetry of this device. So rogue devices, botnets, attacks are just a matter of time, because there is like, the security here is quite limited. The robustness is defined here as an ability to withstand the harsh environment of modern factory, like temperatures, variable temperatures, vibration, the lack of temporal lack of connectivity, like dust and things like that. So yeah, the devices needs to be quite specifically designed to work in such environment of the latest and greatest factories or plants, to be able to live through those decades of working and serving of the needs of the factory. This means by the robustness. The scalability, this is a new thing. It's not being too well known in this distributed control system, the DCSs, which was the precursor of the IoT, industrial IoT. But the scalability and extensibility is the aspects of planning for the lifetime of the devices. We are not talking about the 2 years lifespan when the front-end application will be completely revamped to another one. In the front-end world, that's quite normal. And the device world, that's not normal. We are talking 5, 10, or 20 years when nobody touched the edge or a leaf device. So with that in mind, we need to create this scalability and extensibility in both hardware and software. With software, we have a lot of means to do that. In hardware needs to be more buffy than usually it have to be. So to firstly accommodate for the situation when the security standard will extend, when there will be more demand from the hardware perspective for the running up the application and so forth. So this is quite unique, especially from the device perspective, that we need to be sure that we plan for that actually on the design phase. And the fast, flexible, and accurate, that's like everybody wants that. And that I think is quite self-explanatory. So this is the theory and how it looks from the practice perspective. Like from practical perspective, some of you may be familiar with these 3 digital layers of company. Like we have a device layer, this is the SCM, the DCS naming convention, let's call it like that. We have this device level at the bottom when we have those robots, press shops, and PLCs, so programmable logic controllers, which are basically gathering the data. After that, we have the SCADA system, which is basically stands for supervisory control and data acquisition. So basically gathering the bunch of those data in the more usable form and allowed to act on the scale of the more of the like production line, not just the single units of robots. And higher we have a MES, which stands for Manufacturing Execution System, when we think about the whole site, so whole factory, not only single production line. And for each of the other sites, each of the other factories, we have also MESs. And at the top, we have ERPs, CRMs, and SCMs, which basically are in the high quarter, and there from that we manage the whole enterprise there. So to compare that to industry IoT, this is the typical example when what we have right now, the left part. And the right part is information how IoT can interact, industrial IoT can interact with pre-existing systems. So basically, when we compare that, we can see that first, the IoT is more distributed. It can be lying on the device level, on the machine and application level, on digital like factory line, or even enterprise level. So it's cross levels. And the second is by nature, it's not hierarchical. The solution that we are building from the industry IoT perspective, they are targeted to the audience when they're cross products. We're not thinking about single customer. We are thinking about the value that we want to give this customer for them to build their own SCADAs, messes, and PLCs. So this is quite intricate design of interleaving patterns that the industry IoT needs to extend and build something upon it. So it's a bit, from one perspective, you may see this as a legacy. From another perspective, this is also a place for a change, for more effective data flow and more effective products. That's it. Okay, and last but not the least, there is a second catch. The typically scaling is a bit different. On the cloud, we have like from the typical mass-produced user-centric content application like YouTube, Facebook, we have millions of users creating like millions of entries in pictures, videos, or posts on Facebook. And here we have something different. We have those thousands of sensors which are working across like hundreds of sites, and they are sending telemetry non-stop, and they are more and more being sold, like 20K per year or 30K per year. It depends on the product line. So whatever you think that it's large, you probably think too small. And this is the most revealing fact that I have been astonished recently, or like basically every week, that we need to go more. So short story, recently I was supporting experimental use cases, a few of those, and on one of which there was one plant, one factory, which was relatively small, like six devices. But the ingress rate, so like how much data is being pushed to a cloud in this case, was 200 gigabytes per second. And the question is, like, first question is, do they really need as much? A second question, at least in my head, was, since the data transfer was like 20 hertz, so 20 times a second, we still need to think about and plan for 10 or 20 years, and we talk big. So downscaling, so there are specific techniques that we can achieve to minimize the storage or the transfer to those levels, from and to those levels. But we are talking big, like big data, and especially from the ingress perspective. Cool. And the second topic would be the security. You may have heard the famous phrase that letter S in IoT stands for security. And unfortunately, it's still true, especially in home automation and smart cities. This is so true, and yeah, that's extremely unfortunate. Since 2011, we are observing a rapid growth of the IoT all over the world. And low security is a common denominator. And I remember multiple conference talks a few years ago when all of that was exposed in great details. Security got improved, and I have a lot of good words for smart homes, smart cities recently. But today's issue are basically two. First is the botnet activities. So IoT devices are great for botnets since they are basically machine-to-machine communication, and supervision may be lower here. And additionally, the poor implemented security with recently, like a week ago, with at least two hardcore Bluetooth vulnerabilities have been found, which will impact a lot of clients. So we should be fully aware of those. Pop quiz. What is the percentage of inadequately secured devices with non-firmware security flaws in firmware? And since this is not an interactive session, you can put your comments in the comment section on Hopin. But yeah, it's the answer might be quite astonishing for you. 83%. This is based on the routers and other small devices study done by American customer industry, and it's like it's still being an issue, and numbers dropping, which is good, but we should still have be very cautious about that. So recently, the botnet attacks, 500,000 devices taken through the 13th days, and the botnet produced around 300 million requests per minute. So that was a big thing. And the root cause was the devices were never updated nor patched. And it's typical in the industry IoT that this kind of security misconduct will not fly. None of the big companies will allow to a situation when they can do something, but they didn't. From the security perspective and from our own Polish garden, or backyard to be exact, 2 years ago, I was on the security conference, or 3 years ago, and I was talking with the researchers from Ireland about the state of the Polish IoT and the security there, which was quite sad at that time. It's a bit better, but it was at that time quite sad. And he was showing me and his recent research, which was one of the company which in Poland that was responsible for like milk product producing, so dairies. And all of the homogenization process were exposed publicly using, of course, role-based access control, but the server was available with the heartbleeds on it. So taking over that server would be a child's play for people who are actually aware. And at least 3 times this researcher was approaching the company to patch this, and eventually they did, but it took like 2.5 years to do it. So yeah, we should be quite aware of that kind of situation. Data ownership. The cool feature that you may heard about is multi-tenancy. So from the software perspective, multi-tenancy is like sharing the resources between a dedicated space for end customers. And this is extremely important from the cloud perspective. Otherwise, we would need to have like sacrifice or isolated resources for just a single customer. So we need to find balance here. And it's quite generic concept from the software perspective, but it has the consequences. For example, when we are on isolated resource management, we will need to pay more. And if we will decide on as an end customer, and when we will decide that basically we would like to share the resources, it means that if the service is down or has some noisy neighbor situation, we can have not the best support or the best kind of service that the end customer would like to want. And those are the struggles that we are thinking very carefully about. And there's the second part of the data ownership that I want to discuss. It's related to data ownership. And it's extremely important for the end customer and it's also important for the customer, like us, from the people from the, who are buying home automation or any other products right now. Companies like Google, Facebook are basically selling our own data to the other companies to, for example, better target the adverts to us. And this practice will not fly also in the industrial IoT, because we are talking about confidential data related to the producing of the or products which are specific to either customer. So we need to be quite precise here. And the data ownership and how to duplicate or access to define the ownership of the data itself and access to the data itself, it's extremely difficult in IoT world. And this is one of the things that we also need to figure it out case by case. Sometimes the device is being manufactured by company A, the end user is company B, the third party is selling the product, and the support is being delivered by company D. So we have 4 legal entities which has different parts of ownership of the data. And that's quite standard. It's not like we just give the particular people the role-based access control. It's not only that, we need to also provide them ability to be forgotten. So clean up the data when they decided that they no longer will use our service. And for me, the most infuriating thing is data hostage in the industry IoT and the Internet of Things by extension. So my best description here would be like, this is the worst thing that we can do in any IoT from any IoT solution perspective. Last but not the least would be the topic of data processing. So when you will go to Microsoft Azure or AWS documentation pages, you will find reference architecture for your own IoT platform in a matter of minutes, like that. And this will give you a good starting point for further discussion, but it's usually not the thing that you're actually looking for, because most of my clients, they don't know what they want at the end, since the domain is quite new. And we need to start somewhere to build the same vocabulary, and then to start building a solution which is specific or generic enough for both. And what I mean by that, next story time. So right now, the most struggle that I have is the generic versus specific. So the project that I'm evangelizing for is a bit the platform, IoT platform called Ability Platform. And right now, the most heated discussion are about the internals of it. So the challenge here is some of the clients would like to have a configurable car, but working car, like the whole thing, which you just get the keys and start driving without waiting for anybody. But others, they have more experience and they would like the customized parts there. And there is a cost related to being more generic versus more specific. If you start with this reference architecture of IoT from Microsoft, based on it, you can create your more and more specific solution. But there is also an alternative. It will work for you, this kind of solution. It will work for you, but would probably not work for others. Since, for example, the warm path versus cold path processing would be different. The edge tier, so ingress rate, would be different. Same goes for the enterprise, which is analytical tier. All of that stuff inside of these actions or things may be completely different. So to remedy, you can build a generic solution. And with generic solution, It's really a research to create a solution which will work fine for most of the use cases. And it will be exponentially more complex just to compared to adopting the referencing architecture for your use cases. And for starters, you can start with reference, and you even should start with some reference solution. And then when you will know what you would like to have at the end, at least you will have more knowledge of your requirements here, we can talk and discuss about what is needed, what's required, what is no-brainer, and so forth. So that's a hidden complexity, which is not seen on the first glance. And this is actually how I'm seeing that. There's like domain of control for devices. There is domain of information of devices. All of that may be different for each of the customers, and usually they are. So creating a generic OT, so like IoT in this case solution, it's extremely difficult from the technical point of view, because what we're actually doing is PaaS, so platform as a service, not the SaaS, software as a service here. And second is like the complexity of end-to-end solution. Even if we have a great enterprise, so great analytics or a great platform in the cloud, if the ingress, so edge tier, it's lacking, we will not have a great end-to-end solution. Same goes for switching those components differently. And more and more, I see the consolidation in the thinking of industry internet reference architecture that's capturing all of those discrepancies. So this is the most demanding part when the software architecture, software developers are extremely in need, and we are looking for bright talents that can move the whole area of industry IoT forward. So this would be the part that it's most difficult to get from the reference architecture into the monetization. And it's not only a software, it's not only a system, not only a project, it's a product. So from that perspective, and with all that in mind, we should think about the whole topic. And as a summary of my talk today, I would like to leave you with the few most important parts. That those 5 slides are most important from, at least from my perspective. First one is like, there are existing brownfields in the industry IoT, and we can extend them and make the whole system better by implementing the industry IoT standards and Internet of Things as a whole there, to provide better support and products for the end customers. The scale of IoT is ridiculous. I don't have anything more smart to say about that. The scale is tremendous, and design thinking or architectural thinking without having at the end of your back of your head the scale will lead you to very interesting problems that cannot be easily solved. Security is a must. There's no option. Like industry IoT without security doesn't exist. And if you have an experience with the home automation, that's cool. If this will work on ESP32, that's cool, but it will not fly on industry IoT. Multi-tenancy is a great concept, software concept. It may apply to a great deal of the end customers, but will not apply to all. And that's okay. And we should live with that and give the ability to our end customer to be flexible here. If they would like to pay for a house here, let's let them do it. Otherwise, they would stick with this flat in a apartment. Last but not the least is the hidden complexity. And the hidden complexity is not visible on first glance, and it's generic versus specific. So I urge you to look into those reference architecture. After this talk, I would gladly talk with you about that for hours, if you will not stop me. So there are the things that are not seen on first glance, and would be cool to actually think them through when you will go to your clients and when you will start working for your own IoT or industry IoT projects. And yeah, thank you for joining me today. I hope this talk was interesting for you. And if you would like to discuss it a bit more, feel free to contact me on Hopin after this talk or in a formal Q&A. I would like also to invite you for, I think, more technical session about the same topic from my great friend, Paweł Fiderek, today at 5 p.m. at same track. Please say hi from me and give shout out to him. And I give back the floor to the studio. Thank you.